All right, everybody, hear me okay?
Yes.
Yes, sir.
Yeah, I'll put my microphone here, it's better. Okay, so today let's finish chapter 8 and start chapter 9. Chapter 8 is the appendix, so we don't have slides for that, so I'll go freestyle as usual. But then I advise you to read the textbook. It's I think it's a good complement. I have my way of teaching stuff, which may be a bit more analytical, but at least it's structured and we see where things come from. And then you can have the textbook, which is much more literal, and then so you don't have that much math in it, but I think it's a good complement. And then we're going to start chapter 9, competitive markets, or at least it's firms in competitive markets. And here I thought the slides again were difficult to follow. So I think I'll go freestyle for chapter 9 too. All right, so it's freestyle the whole way today. I don't know when the results of the midterms are. I don't control that, sorry. But I'm surprised they're not out yet though. So there might be something strange going on. All right, so let's go ahead and I'll share my screen. So again, so this is the chapter 2, the appendix to chapter 8. Okay, I've started that. All right, so isocons, this is an important topic in microeconomics. It's much related to the consumer theory, so you should see lots of similarities. Stop me anytime you have questions about what I'm saying. So what are isocons? So they describe all combination of inputs, of two inputs generally. We'll do more, but two is enough to understand what's going on, which allow to produce the same quantity of output. So for instance, you could have a lot of capital and few workers. So a very advanced economy, like Japan with robots, for instance. Or a few machines or little capital. And lots of labor. So that could be China in the, let's say, 1990s, because the labor was abundant and capital was scarce back then. Now China is much more advanced, so I wouldn't say China now. They have they're super advanced in AI in many different fields. So, but yeah, back then it would have been the case. So, and the thing is, so both would allow to produce same quantity. And of course, let's represent this graphically. So we would have some, or let's go bigger. Let's be ambitious. So this would be, for instance, labor input, or L. This would be capital. This would be, for instance, production of let's say 10 ton. 10 tons of something. I don't know what. 10 tons of cars. Yeah, 10 million cars. So we can produce 10 million cars using different combination of inputs. So where is Japan in this on this graph? Is it this way or this way?
Up in capital.
Yes. So Japan would be somewhere like here. And here we would have China. Okay, so what can we say about this? So what is the slope of isocant? So properties. The slope isocant is positive or negative?
Negative.
Yes. Because what does that represent? This is the hard part. Saying it's negative, you can, if you know a bit of math, you see, oh yeah, the slope is negative, I see that. But then, oh, economics is about thinking about what you're talking about, looking at the graph, and then making a connection between the two of them. So somebody has a clue?
Would it be opportunity cost that it represents?
Not yet. So opportunity cost has to do with what I can buy or what I have to sacrifice. Here, it's I could. So there are many isocants. I have another one here that is not 10 million but 12 million, for instance. So it's not exactly that.
Because if you put more capital, let's say, then you'll be able to produce more cars. Or if you want only 10 million cars, it'll take less labor.
Yes, exactly. Because if in my firm I add more labor, production would increase. Well, okay, let's just write it this way. I must reduce the amount of capital such that production stays the same. All right. That's just that. So if I start from there and I increase the labor by a certain amount, then I would be, of course, producing more. So I would end up on a new isocant. So the only way to stay on the same production level is to then decrease production, decrease the capital. So I can go back down to the same amount I had before. All right.
Yes, we don't. Oh, okay, never.
Yeah, I thought that was okay. And now, so that's property number 1. So property number 2, a bit more tricky to solve. So isocons are convex. So the slope becomes flatter as we increase and decrease key. Why? So if you don't know math too much, convex just means that it looks it looks this way. So from the horizontal axis, and concave would be this way. So this is concave from the horizontal axis, and this is convex from the horizontal axis. But don't worry about it. It's just a precise way of saying it. But the question is why? Somebody want to take a shot at it?
So because at some point, the more you add labor, like the less they're productive.
Exactly. Wow, you're on fire today. So has to do with decreasing marginal product of single input. Do I have some space there? Yes, okay. Here we go. So how do I know what is the slope of the isocant there? So let me show you. So this is the most complicated we're going to do today. Slope of an isocant. All right. So imagine that I produced a certain amount, so production is going to be F of LK, right? So it's a function of how much labor I have, how much capital I have. Yeah. So now imagine that I increase the amount of, I change the amount of labor, or I change the amount of capital. What happens to my production? So what happens? When I change L or K. So here's what happened. So it's going to change, and that change will be delta F, which it will be equal to delta L multiplied by the marginal product of labor. So this is if I increase the number of labor I have by 2, for instance, how is that going to affect my production? It's going to multiply it by 2 multiplied by the marginal product of these workers. So if each extra worker produces 10 units, then it's going to increase by say 2 multiplied by 10, which would be 20 units. Same thing with capital. So if I also change the number, the amount of capital I have, then the change in production will be delta K, the change in capital, multiplied by the marginal product of capital. So if, again, marginal product of an extra machine is 100, and I increase the number of machine by 1, then the extra units produced will be 100, more or less, because yeah, it would be exactly true for small changes, but this is more or less true. And now for an isocant, I want delta F LK to be what?
0.
0 exactly. So what do I get? I get this. Delta L times the marginal product of labor plus delta K times the marginal product of capital is 0. So let me just rearrange this. So let me put this on the right hand side. And I get this result there. And then what I can do is divide by a delta L on both sides. So delta K divided by delta L equals to minus marginal product of labor divided by the marginal product of capital. So this is the slope. This is the slope of the isocant curve. So let me just use a nice box because this is important.
Sorry, I have a question.
Yes, now questions.
A big change. Like if we add more labor, then the marginal product will decrease. So what marginal product do we use? The first one, the second one, the average?
Okay. Short answer. So you don't have to worry about it. Because all I want to do is show you where this slope comes from, because this is in the textbook actually. So this you might have a question about it. But when you become older and you learn some mathematics, so you're not going to write it this way. You're just going to substitute these delta by these here, and this will be the derivative. And in this case, then it read, so this is at the exact slope at an exact point. So yeah, so this is why I said it's approximately true, not exactly true, but in the old class we've always been using deltas, so I keep the deltas there. But it's a good question, but it's really going too far, making things too complicated. It doesn't.
Can you lower the because I don't see the image completely.
Oh, so is my.
Comme juste monter par en haut un peu. Ouais, ok. Et aussi, oui, est-ce que, can you give an example of KLMPK, marginal product of L, like what? Because sometimes I'm like confused.
Yeah, no, it's normal. So example, if marginal product, yeah, so I'll just say, so by the way, first of all, okay. This is annoying though, the fact that you don't see the whole screen. So it means I have to not use the whole screen. So let me put this higher. Higher. Okay. So where MPL is marginal product of labor, and MPK is marginal product of capital. So example, so MPL is 5 and MPK is 100, for instance. So this means that if I add an extra worker, my production increases by 5. And if I add an extra machine or extra unit of capital, my production is increased by 100. So what would be the slope of the isocant? So slope would be equal to delta K. Delta L is, so what would it be? Minus 5 divided by 100. It's minus 0.05. And of course, so the marginal product of labor is as some value that is at some point. So if I have, say, 10 machine and 5 people, then or 10 machine and maybe 100 people, then I know that then the marginal product is 5. But if I had more machines, then the marginal product would change. If I had less workers, then my marginal product would change too. So this is true at some point somewhere here. And so if I ask, for instance, if I'm here, what is the marginal product? So I have to ask myself, what is the slope? Then it's what is the marginal product of capital? What is the marginal product of labor? And when I know that this is the slope. So I see that it is negative. It's what we said, because if I add more labor, I must reduce the amount of capital. And of course, the marginal product of labor is positive and the marginal product of capital is positive. And then we also see that what happens when we have a lot of labor and little capital. So if I have lots of people work in my factory, then at some point they're not as productive as before because there's decreasing marginal product. So MPL is small and very few machines. It means it would be very, very useful to have an extra machine because I have so many workers to work with. So MPK is large. So if MPL is small and MPK is large, so the slope is flat. So it's exactly what we're saying there. If the capital is very little and labor is very large, then the slope is flat. And here is the reverse. All right. So this is this is the much more math, I would say, than what you have in the book. But what I have a struggle with in the book is that they just throw at you stuff and they say things, but they don't justify anything. So here, at least we have some inkling of where things come from. All right. So let's. So that's the basic thing. So you can think about if you have questions about this while I continue. So let's.
So I have a quick question. How would you plot, for example, the negative half slope for an isoquant thing?
Okay.
Like, can we have an example where we have numbers and then where you plot it and you put it on a graph?
Oh, you mean with a certain function and yeah. So so I haven't looked at all the exercises that you are going to have to solve for your, but I'm pretty sure it's not going to go that far. So
We have one on the lab that asked us to plot it, and I didn't get it right because I don't know how to do it.
okay, so well, so yeah, I would really have to read it and see it carefully. So maybe after the class we can discuss about it. Yeah. One thing I could give you. So let me change my example then. So imagine that's 5 and that's 10. Okay, and we are. So marginal product of labor is 5 and marginal product of capital is 10. So probably we're somewhere like, so I want a slope that is 1/2. So it's about here, for instance. Yeah, the thing is it should have a perfect curve. So it's about here. And here it would mean that I increase by 5. Oh, I see the previous question. It's what do I use? Do I use the starting point or the end point? I think you would use half. So let's say it's 2 and 1. That would be easier. Okay. So imagine that I have marginal product of labor that's 2, and that's 1. That's, yeah, 1, and marginal product of capital, that's 2. Yeah, so the slope would be then -1 divided by 2, so minus 0.5. And we would get that, so it would be a slope that would be, when I increase by 2 units here, I decrease by 1 unit there. More or less. So imagine that's 2 units and 1 unit. So this slope minus 0.5. Does that answer your question?
Yeah.
Okay, good. But so if it's still unclear, we can talk after the class. All right. So continuing.
I have a question
Yeah, go ahead.
concerning this graph that you just drew. Because on a curve, like a convex curve, it should be like at each point, it would be the different slope. So in this case, which point would be the 0.5 slope?
Okay, it's just I cannot draw infinitely curved. I have to draw it by segment, but so it would be here exactly.
Like in between those 2 points, is that what you're saying?
Yes, yes.
Okay.
But it's true that that's the how difficult it is to teach this class is we always talk about discrete changes, but at the end of the day, the slope is completely curved. So as soon as you increase by delta L by 0.001, then the slope starts to change. So I can't say, yeah, it's about here, but it really changes at every point. Now, how you answer the questions on my lab? So yes, this I cannot. I have to see them.
Is it usually, what's it called? Is it usually the most efficient output of production where you would find the slope and then draw the slope, and then from there draw the isequant line?
So I will get there eventually. Yeah. So what is efficiency? Well, it depends. Yeah. So here is for all the combination of the least amount of capital and labor I can use if I want to produce this this production of 10 million cars, for instance. But then so what I'm going and then is the how do you minimize costs? So I'm going there. Don't worry. Okay. So just before that, I just want to show you a small thing. So special isocons. It should remind you of things we've seen before. Perfect complement. And perfect substitutes. So perfect complement isocant look like this. So I can draw another one. This, for instance. And the example I like to give is, say I have a student and a pencil. This is number of exams written. So what does this say? Well, it says that if I have, say, 2 students and 2 pencils, then if you increase to 100 students, then they don't have pencils, so they can't write an exam. So they are perfect complements. I must have the same number of students as pencil to be able to produce more exams. So that's for perfect complements. Now, perfect substitute, somebody has an idea what it should look like?
Is it a straight line?
Yes, straight lines. So like this, for instance. And here what I like to give as an example is say lazy worker and efficient worker. So what this means is I can choose, if I can pick the workers I like, then you see that if I'm here, for instance, then I can add 2 lazy workers and get an extra production, or 1 efficient worker. Yeah, maybe I should make this even more obvious, like this. And here, they don't have to work together. It's just like I need a certain number of worker, and so if I add extra or lazy workers, then my production increases, but I can add a lower number of efficient workers to get the same increase in production. So here they're perfect substitute. They don't have to work together. All right. questions about it? I think it's quite obvious. This is called, by the way, Leontief's curve for a famous Soviet economist called Vasily Leontiev, who was trying to plan the whole economy of the whole USSR. So at some point, he had to make things easier. So he would say something like, oh yes, to produce one television, you need exactly 10 screws, one screen, 2 planks of woods, and he would have all these description of all the ways you like if it was an IKEA furniture. And then what all it's saying is you cannot deviate from the plan he gives you. That's the only way you produce a TV. You cannot produce in any different fashion than that. So it's really looks like everything is a perfect complement. Obviously, it was reality is more complex, so you can substitute stuff in real life, and people always do. All right, so last thing about isocons, cost minimization. So it looks quite a lot like utility maximization. So if I have my isocant there, so let's go back to labor. And capital. I have my isocant here. So in real life, it's possible to substitute somehow labor and capital. And I want to minimize cost. So what do I do? Well, I have to have an extra curve that's called, put that in red, an isocost curve. So I have that one, nothing special about that one. And then that one. All right. Combination of inputs that cost the same. So this looks a lot like a budget constraint, but it's not exactly this. So why is it? Why are these curves first of all negative? Because
if you put more money for a worker, let's say you have to take less money for something else.
Yes, exactly. If I hire one more worker, I must use less capital to spend the same. And so what am I trying to do? Well, obviously these cost more as I add more capital and labor, and these cost less. So what am I trying to do? Well, this is the production level I want to achieve. And I'm trying to find this isocost curve, which costs the less. So what curve would that be? Would that be that one, 1, 2, 3, or 4?
3.
Yes, well deduced. So this is my optimal production. So, sorry about that. And by the way, what is the slope of an isocost curve? So let's do the same thing we did, but with cost. So cost is, say, C equals to labor multiplied by price of labor. So, or yeah, let's say wage plus capital multiplied by rent. Or plus wage. R is rental of capital. So let's do the same. So imagine that I increase the amount of labor or the amount of capital. What's the impact on cost? So it's delta C equals W times delta L plus R times delta K. And for an isocost, what is delta C equal to?
0.
Yes, if I want things to cost always the same on this isocost line, so I get that it's equal to 0. So let's put this on the other side. So I find that delta K divided by delta L equal to minus W divided by. So at the optimum, so that's the slope. Isocost. So at the optimum, so the slope of the isocost has to equal the slope of the isocant. So I get that minus W R equals to, what did I have before? I forgot. Yeah, minus MLP divided by. So I find W or R equals this. And this is what you have in the book. So this is where it comes from. So I'm uncomfortable to just having you remember things and not knowing where it is. So this is it. That's at the optimum. Or another way to write it is this. So MPL divided by W equals to MPK divided by R. So in the real cost of capital has the real product of capital has to be equal to the real product of labor. All right. Questions, uncertainties, comments?
Professor,
Yeah.
if they only give you 1 point, how can you find the isocast curves?
If they only give you 1 point, well, they have to tell you what is the cost. Yeah, they have. So what is the? So they want you. They want you to derive the formula for the isocast curve. Are you sure?
No, it was just a hypothetical. I
Oh,
didn't
okay.
learn the light.
It's yeah. Thing is, we can just dig deeper and deeper, and it's yeah. I'm going to lose everybody. If so, I want to stop here
Alright.
for this because we have to move on to the next chapter too. So this is cost minimization. This is what you find at the optimum. So, oh, and by the way, yes. So last thing, if the relative cost change, so for instance, if labor becomes cheaper and capital becomes more expensive. So if, for instance, you get this, then what are you going to do? Well, you're going to produce with more labor and less capital if here labor cheaper and are relative to capital. Yeah. So this is, so we're not saying something like, oh, we used to spend this amount, now the price of labor increases, so we shift and we have a lower production. Now the question is, what is the lowest possible amount I have to pay to produce this? So all we care about is the relative price of each input. So here, for instance, if labor is cheaper relative to capital, so it means that my curve is going to become flatter. I can afford much more labor and much fewer machines. So then my choice of production will become here. All right. So, okay, if you don't mind, I might like to move on to the next chapter, which will be simpler, don't worry. But I'll do it freestyle again because the slides are difficult to follow, in my opinion. So again, what I suggest is you may read the textbook and use this explanation too. I think it's the best combination. The slides they don't have the okay, so firm chapter. So that's chapter what, 9?
Yeah, 9.
Yeah, chapter 9. So it's firm here in competitive market. So what happens in competitive markets? Firms do not, or single firm do not affect market prices. So they are very small. So no matter if if I produce tacos, and if I produce 50 tacos today or 100 tacos today, it doesn't matter. The price of tacos all over Canada is on average going to be the same. So it doesn't totally make sense, because somehow I have this small niche market on the corner, and you imagine that people, if it's close to their work, they will still like to come to buy tacos in my shop. But what we assume is I cannot change my price of tacos. If the price of tacos is $10, then if I sell it at 10.01, nobody's going to want to buy tacos at my shop. So what I could say is something like things on Amazon's. If two objects are exactly identical and you can click on one or the other in Amazon, then you click on the cheapest. That's it. So that's the single most important thing about competitive markets. And what we're going to see today is the short run. So and we're going to ask 4 questions. One, if a firm produces, how much will it produce? 2, now that we know if the firm how much it will produce, if it does produce, then we can ask the question: will a firm choose to produce or stay closed? So could still in business, but decide that it's not worth it to open the door today. 3, what is the firm's supply? Or short run. Yeah, everything is short run. And 4, what is the firm profit? Okay, so to understand that, let's go back to what is the profit. Profit of the firm. So we write it, capital Pi, which is equal to total revenue minus total cost. Here is total revenue. TC is total cost. And Pi is profit. All right. Now the question is, what is the, and then I can replace total revenue by what is the revenue of a firm? If I sell my tacos, so what is my source of income? If I sell 100 tacos at $10, so what is the total income?
1,000. It's the number times the price.
Yes, it's market price multiplied by the quantity produced. And what we're going to say is, since single firms don't affect the market price, then P is just a parameter. It's not something I can choose to change. The only thing I can choose to change is Q. And then the question is, how much should Q be? So question 1. How much?
Professor,
Yeah.
will we have slides for chapter 9?
Yes, you have. There are slides. It's just that they're confusing. Yeah, yesterday I was looking at them and thinking, oh, how should I jump from this to this? And there are typos in them, and I thought, okay, no, I'm just going to. But so what I would advise you do is maybe not look at the slide, but read the textbook and use these things there. So everything that you should need to answer the questions should be in here.
All right, thank you.
All right, so I should produce from so as to maximize profit. That's quite obvious. So imagine that I'm producing some unit. So if I'm producing 10 and I'm asking myself, should I produce 11? So, well, how is an extra unit going to affect my profit? How do I see that? So if delta pi equals to P times delta Q minus delta total cost, that's been increased by that's been caused by an extra unit. So if this is larger than 0, so what should I do then? I increase the production by 1 unit, and my total change in profit is positive. What should I do? Should I increase by 1 unit or not?
Yes.
Yes. Produce more. And we're going to write this as divided by the increase in units. So in marginal terms. So in marginal terms. So delta pi divided by delta Q. I just divide by delta Q is so so this is the, yeah, let's leave this there, and this, the delta Q's disappear. And here, what do I have? Delta total cost divided by delta Q. Somebody remembers what this is? We've seen this 2 classes.
Isn't that marginal cost?
Yes. So yeah, maybe I should have written this. Okay, yeah, let's just say that. So if then if this is smaller than 0, so should I produce more or should I produce less?
Less.
Yeah, should produce. So optimal production is when delta profit divided by delta Q equals P minus MC equals 0. So when price equals marginal cost. So that's the big takeaway. What is the optimal production? So if you know how to maximize, it's very obvious. So you just yeah. Oops. Should I? Yeah, I think I can make my graph here. Okay.
P is profit, right?
P is price. Yeah. P is price. Q is quantity. Produced. All right. So let me put Q here and P here. Yeah, the price here. So let me draw my marginal cost curve. So imagine I start like this. Marginal cost goes up like this.
Professor?
Yeah.
P is profit, right?
Oh, pi, you mean? So capital pi. Yeah. And then P. Or in French, P, prix, et P, profit. In English, P, price, and pi, profits.
Okay.
Yeah, it can be confusing. I didn't think about that. All right, so this is the marginal cost. And this is, yeah, it's not very pretty. Let me try to draw it better. So something like this. This is a marginal cost. And this is the price. So let's have market price here. And as you see, the market price is always the same, regardless of the quantity that the firm decides to produce. But obviously, the marginal cost may decrease initially and then increase again. So why does it increase? Because I'm in the short term. So it means that the only thing I can do to increase my production is hire more people. But eventually, to produce an extra unit, I would have to hire 50 new workers, but they can almost do nothing. So that's why the marginal cost increases a lot. Here, it may decrease because workers become more efficient as I get more qualified people and for each job. But eventually, I run out of capital, so my marginal cost increases. And then where is my optimal production? When the price equals marginal cost, as we were saying. So that's right there. And we're going to say it's Q star. Right? So that's question one. So equals MC optimal production. All right. And oh yeah, go ahead.
There's two spots where MC is equal to the P. Does it matter which one it is?
Oh yeah. Yeah, maybe I shouldn't have drawn it that way, but it's possible. So if we think about it, here, what did I do? All these initial units cost me more than market price. And then here is the first time where I produce a taco that brings me a sales price of 10 and a production cost of 10. So here, all I did was wasting money. And here I just start making money. So that would be sort of the worst decision I could make. Here I'm making money because here each unit I sell brings me an income of P, but that costs me a marginal cost that is lower. So here I'm making positive profit. And here then again, I start making, if I continue after Q star, then my extra tacos cost me more than the price. So I shouldn't do that. So I should stop basically here. That's a very good question, actually. I hope that was that answered it.
Yes, thank you.
All right. So really quickly in the time, so that was question 1. So let's answer question 2 real quick. Question 2, will the firm produce? Well, it depends. So the answer is the firm will produce if it makes more money producing, which is quite obvious. But what does that mean exactly? So profit producing. So it's pi equals to P times Q star minus total cost. And let us split total cost into two costs that we've seen before. Somebody remembers?
Fixed cost and variable cost.
Yes, variable cost and fixed cost. Of course, there's a minus there too because it's total cost, which is variable cost plus fixed cost. So there's a minus in front. And what I can also do is the following. So let me put P in front there. And here I'm going to have average fixed cost. So because what is, where PC is variable cost. FC is fixed cost. Here, AVC is VC divided by Q is average variable cost. So here, all I did is divide by Q and multiply by Q. Oh, yeah, sorry. That's not what I intended to do. It's this. Yeah. So what I can do is multiply by Q and divide by Q. So VC divided by Q is AVC, and then I can put Q in front. Yeah, maybe to not confuse you, let me just add a step. Yeah, so I can go fast in my head, but yeah, times VC divided by Q star multiplied by Q star. Yeah, so it's a bit confusing because I have Q star and the multiplication there, but so let me put it in front then. Q star times VC divided by Q star. And then what I can do is put the Q star in front, and this VC divided by Q star is average variable cost at Q star, of course. And now what do I get graphically? I get the following. Marginal cost, and this is the price. This is P, this is Q. Oh yeah. This is Q star. And now let me show what is the average average variable cost.
Professor,
Yeah.
could you re-explain which point should we use for questions like that? Like right now we have 2 points where P crosses the marginal cost.
Oh yeah. You have to produce the highest quantity every time because here you're making money because the marginal cost is lower than the price. So my tacos cost 5 to produce, and I sell it at 10. But here for the initial section there, I was losing money for my first tacos because I wasn't super productive. So producing at this quantity would be the worst possible decision. It would be a minimum. It would be the sort of minimum profit I could make. And this is the maximum profit I can make.
Okay, thank you.
And then what is the average variable cost? Very quickly, it's actually, let me start this at 0. That would be more obvious. And the average variable cost is something like this. So let me use green, for instance. So this is average variable cost. Why? Because as we've seen, the average variable cost is crossed at its minimum by the marginal cost. Because here I produce more and more and more efficiently, so the average variable cost decreases, 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 but then it increases here. Yeah, so this is, oh yeah, one thing I didn't see. Then profits. Not producing. So I get, this is 0. So this goes away, but I still have the minus fixed cost to pay. Why? Because my firm still costs me money. I know I'm over time, I'm almost done. So then the decision is firm will produce if what? If P minus AVC is positive. If this is positive, then profit producing will be higher than profit not producing. But if this is negative, then it's only getting worse if I start producing. I have to pay the fixed cost anyways, plus I'm losing money on my tackles, for instance. So it means that will I be producing? So the question is the price higher or lower than average variable costs? Well, it's higher. So here, in that case, so it is better to produce. So that's two questions. Now the two last questions we're going to see at the next time, unless there's a final question before I let you go.
Thank you, Professor.
All right, thank you. So have a nice day.
All right, thank you. Have a nice day. Bye.
Bye.
Thank
Bye.
you.
Bye, sir.
Have a good day.
Profit not producing, what does that mean?
If I choose, if it's not producing, Q equals 0. So the firm has a choice, either produces 0 or it produces Q star. So if it produces Q star, then the profit is this. If it produces 0, then this is just 0. So I get just the minus fixed cost. So is the profit while producing bigger than the profit if the firm does not produce? It depends, is this term positive or negative? Q is always positive. So it depends whether price margin minus average variable cost is positive or negative. And here it's positive. Price is here, average marginal cost is here. So I know that the firm is going to be producing.
Professor?
Yes.
For the second midterm, do you know what chapters will be included?
Yeah, I can tell you this right away. Uh, 6 to 10.
All right, thank you.
And are we going to have more time than the first one? Because it was very short, like 50 questions for 1 hour.
Yeah, I felt too that it was short. So I think they make it this way to make sure that in a way you don't have too much time to just check into your books or do whatever, you have to be quick and to answer all of them. So that's somehow making sure that everybody's being honest. So I don't know whether they're going to change it. My intuition is no, I think it's going to be the same.
There's a
Okay.
question on the chat.
Yeah. Oh, question on the chat. Let me see that. So, okay, I will ask. How about that?
Sir,
Okay,
I do have a question for you. Sorry. I do
yeah,
have a
go
question
ahead.
for you, but I'd like to just ask it like in private. It's not related so much to the class. It's more like personal.
Okay, so then we end the stream right here, and we can connect back in 5 minutes.
On this same link?
Yeah, same link.
Okay. Thank you, sir.
Thank you, Professor. Have a nice
Yeah.
day.
Have a nice day. So 3, 2, 1, finished.